Friends, this is B. Praveen Kumar, lecturer in chemistry, GDC Gambirapet, Rajanna Siricilla district, Telangana state. Uh, in this class, going to discuss about chemical shift, which is the backbone of NMR spectroscopy, proton NMR spectroscopy. So I would like to share some of the main important points regarding chemical shift. And what is chemical shift actually? The shift in the position of NMR absorption, which arises due to shielding or deshielding of protons, which is arised due to shielding and deshielding or deshielding of protons by the electrons, is called chemical shift. Chemical shift values of various protons is indicated by parts per million, that is in delta or tau. This is the definition of chemical shift, especially the shift in the position of NMR absorption. It is called as chemical shift. Two terminologies are there, one is delta and one is tau. What are the factors influencing chemical shift? Especially the four factors are there. One is inductive effect, anisotropic effect, hydrogen bonding, here hydrogen bonding, van der Waals shielding also is there. So first let us see why shielding and why inductive effect. What is inductive effect? Actually, we know, especially inductive effect is just because of electronegative atom. Here also the same. A proton is said to be shielding. It is attached with an electronegative atom or group. A proton is said to be shielded. It is attached with an electronegative atom or group. Greater the electronegativity of the atom, greater the deshielding caused to the proton. If the deshielding more for a proton, then its delta value will also be more. Example, methyl CH3 CH2F, ethyl fluoride. In CH3 there are 3 protons. In CH2 there is 2 protons. So in this molecule, two signals are able. So two signals are expected for the compound. Protons B are comparatively less deshielded from protons. Why shielding effect? Hydrogen nuclei in a molecule are surrounded by electronic charge and shields the nucleus slightly from the influence of the applied field. Thus, to bring this proton to resonate, the applied field is the increased to overcome the shielding effect. In a magnetic field, the electrons around the proton are induced to circulate and thus generate induced magnetic field, which opposes the applied field. Greater the electron density circulating around the proton, greater is to the magnetic field and greater will be the applied field required to overcome the shielding effect. This is the most important point in the chemical shift actually. Of course, this is the most important slide in this presentation. Greater the electronegativity of the atom or group, greater will be the shielding effect on a proton. Greater the electronegativity of the atom or group, greater will be the shielding effect of on a proton. Greater the distance of the electronegativity atom or group from a particular atom, particular proton, smaller is the de-shielding effect. Smaller is the de-shielding effect on it. In TMS, 4 electron releasing groups cause powerful shielding effect, and hence TMS proton resonate at high field. Here the one new compound is there, that is TMS. TMS means tetramethylsilane, and here it is the main important compound, which is the referral compound actually. That is the reference compound to find out the chemical shift. The shift from the TMS signal is treated as chemical shift. The distance from the TMS signal is it will be the chemical shift actually. So the TMS, in TMS 4 methyl groups are there. The 4 electron releasing groups, of course, these electron releasing groups cause powerful shielding effect, and hence TMS proton resonate at high field. Van der Waals de-shielding. In overcrowded molecules, it is possible that some proton may be occupying statically hindered position. In overcrowded molecules, it is possible that some proton may be occupying sterically hindered proton. Clearly, electron cloud of a bulky group will tend to repel the electron cloud surrounding the proton. Thus, such a proton will be de-shielded and will resonate at slightly higher value of delta than expected in the absence of this effect. So this is about van der Waals shielding. This is also one of the most important things, that is anisotropic effect. This is also called as space effect. That is, anisotropic effect is called as space effect. The de-shielding effect on protons attached to C double bond C is higher than that can be accounted for by the inductive effect alone. Here, this is space effect. The shielding effect on proton attached to C double bond C is higher than that can be accounted by the inductive effect alone. Aldehyde and aromatic protons are much more de-shielded. Aldehyde and aromatic protons are much more de-shielded. Alkyne protons appear at relatively low value of delta. What kind of protons appear at low value? Alkyne protons appear at relatively low value. The values of chemical shift ion. Each case can be justified by explaining the manner in which the pi electrons circulate under the influence of the applied field. Under the applied field. So this is the most important slide, that is hydrogen bonding. As we know, what is the importance of hydrogen bonding? It has been found that a hydrogen atom exhibiting property of hydrogen bonding. Every hydrogen atom exhibits the property of hydrogen bonding. In a compound, absorption or absorbs at low field ion comparison to the one which does not. The hydrogen bonded proton being attached to a highly electronegative atom will have smaller electron density around it. Being less shielded, the field felt by such a proton will be more, and hence resonance will occur downfield. The downfield shift depends upon the strength of hydrogen bonding. The downfield shift depends upon the strength of hydrogen bonding. These are the chemical shift values. Some of the important compounds are there. This is types of protons, chemical shifts in delta value in ppm, actually that is delta value. The first one is cyclohexane. The chemical shift value, that is delta is equal to 0.2. Primary hydrogens, protons 0.9. Stellanic protons 2 to 3.5. Vinylic protons 4.6 to 5.8. Aromatic protons 6 to 9. Alcohols 3.4 to 4. Ethers 3.3 to 4, 3 to 3.4. Esters 2 to 2.2. Acids 2 to 2.5. Aldehydes 9 to 10. So these are the chemical shifts. So especially we have seen earlier, these are the factors influencing chemical shift. Inductive effect, van der Waals deshielding, anisotropic effect, hydrogen bonding. The four factors are influencing. These are the main chemical shifts here. By this I can conclude what is chemical shift and what is the important place of chemical shift in the NMR spectroscopy. By this we can clearly understand the importance of chemical shift in NMR spectrophotometry or spectroscopy. Okay, thank you.